Let's begin our final chapter of Intermediate Algebra, Chapter 9, Quadratic Equations, Inequalities, and Functions. In Section 9.1, we're using the square root property and completing the square. Our objectives are to review the zero factor property, learn the square root property, solve quadratic equations of the form of the quantity ax plus b quantity squared equals c by extending the square root property, solve quadratic equations by completing the square, and solve quadratic equations with non-real complex solutions. The quadratic equations and the zero factor property. In section 6.5, we defined a quadratic equation as follows. A quadratic equation is an equation that can be written in the form of ax squared plus bx plus c, that's in standard form, equal to 0, where a, b, and c are real numbers and a does not equal 0. This is a quadratic equation. The given form is called standard form. Here's an example of a quadratic equation. We have x squared minus 5x minus 36 equals 0. And we then use factoring and the zero factor property to solve this equation. This is what we looked at. We notice that this is a simple trinomial, and we can factor the trinomial by looking at the factors of negative 36 that will add up to negative 5. And the factors of negative 36 that add up to negative 5 are negative 9 and positive 4. So our factors are x minus 9 and x plus 4. So we are able to rewrite this quadratic equation by finding the factors and setting that equal to 0. Then we use the zero factor property and set each of those factors equal to 0. You get x minus 9 is equal to 0, so x is equal to 9. And then x plus 4 is equal to 0 to get x equals negative 4. Now this is our solution to the quadratic equation, and as always we want to check our work. We plug those back into the original equation. Now in this chapter we're looking at some other techniques. Not all of these trinomials can be factored. Not all of these quadratic equations can be factored, so we want to use some other techniques. In this example, we're using the zero factor property. As a review, we want to solve the quadratic equation 3x squared minus 5x minus 28 equals 0. And since this is not a simple trinomial, we can use the AC method. And in doing the AC method, you multiply a times c. A is 3 and c is negative 28. So a times c equals 3 times negative 28, which is equal to negative 84. And then we find the pairs of factors of negative 84 that will add up to this middle term of negative 5. And there are quite a few factors of negative 84, but you'll eventually find the factors that of negative 12 and a positive 7. When you multiply negative 12 and positive 7, you get negative 84. And when you add negative 12 and positive 7, you get negative 5. So then we split the middle term. Keep the first term as 3x squared. The middle term is split into a minus 12x and a plus 7x. And then we keep the last term, minus 28, which is equal to 0. Now we factor by grouping. Looking at the first group and the second group separately, the first group, the common factor that you can take out of 3x squared minus 12x is 3x. When you take out that common factor of 3x, you're left with x minus 4. In the last group, the last two terms, the greatest common factor is 7. So we can factor out a plus 7. Whatever sign of that middle term is, that's a sign that you're going to factor out. Factor out the 7, and then you're left with x minus 4. Now we're looking at the two larger groups. Notice that the two larger groups have that common factor of x minus 4. So x minus 4 is a factor, and the other factor is what you see out in front of those common factors of x minus 4, which is 3x plus 7. We're going to set both factors equal to 0 using the zero factor property. If we set x minus 4 equal to 0, we see that x equals 4 is a solution to the quadratic equation. We set the second factor equal to 0, 3x plus 7 equals 0, by subtracting 7 from both sides. we get 3x equals negative 7, and then dividing by 3, we get x equals negative 7 over 3. So we have two solutions here, 4 and negative 7/3. Obviously, you want to check to make sure each of those solutions check in the original equation. You can write your answer as these two separate x values. You can also use set notation and write it as negative 7/3 is one answer and 4 is another. Now the square root property gives us another way of solving quadratic equations. The square root property states that if x and k are complex numbers and x squared is equal to k, then x is equal to the square root of k, or x is equal to the opposite of the square root of k. Example 2, using the square root property, solve each equation. So we have for example A, x squared equals 17. We can use the square root property to solve to get x by itself. The inverse of that square power is the square root. So the way to get rid of that square power is by taking the square root of both sides. Now if we take the square root of the left side, we also need to take the square root of the right side. But again, the square root property will let us know that we need to consider both the positive and the negative solutions here. Typically, we have an x to the second power of the highest exponent is 2. We should typically have two solutions. So our two possible solutions here, when you take the square root of the x squared, the square root and the squared power are inverses, so this will simplify to x. So x is equal to positive square root of 17, or x is equal to the negative square root of 17. Now you can check both of these solutions in the original equation. When you check x equals square root of 17, you take the square root of 17, that quantity squared does equal 17, and then check the negative square root of 17, that quantity squared also equals 17. So these are our two solutions to the quadratic equation. Now before using the square root property, you do want to make sure the squared term is isolated on the left side. So for example B, we have 3x squared minus 9 equals 0. We're going to add 9 to both sides, and then we'll get 3x squared is equal to 9. Again, you want to get that squared term by itself. So we're going to divide by 3, and then we get x squared is equal to 3. Now we can apply the square root property because we have the squared term by itself. When we take the square root of the left side, we also need to take the square root of the right side, but consider both the positive and the negative outcomes. The square root of x squared, the square root and the power of 2 are inverses, so we get x equals plus or minus the square root of 3. So x is equal to the positive square root of 3, and x is equal to the negative square root of 3. You can check both of those by plugging them into the original equation for x. So 3 times, let's check the first positive square root of 3 minus 9. Does that equal 0? Well, squared, sorry. Doing the exponents first, the square root of 3 squared is 3. So we have 3 times 3 minus 9. That does equal 0. And let's check when x equals negative square root of 3. So 3 times negative square root of 3, that quantity squared minus 9. Does that equal 0? Does 3 times 3 minus 9 equal 0? That is also the case. So we know these are our two solutions. Now we can extend the square root property and solve equations that look like this. The quantity 2x minus 3 squared equals 25. We can apply the square root property. Since the squared term, the entire quantity on the left is squared, the squared quantity is isolated. So we can take the square root of the left side, as long as we consider taking the square root of the right side and consider both the positive and the negative outcomes. You can then take this square root power and that the square root and the power of 2 are inverses, so the left side of the equation becomes 2x minus 3. On the right side of the equation, you want to consider both the positive and the negative square roots of 25. So we can write this as plus or minus 5. You can break this up into two equations, where the first equation is 2x minus 3 equals positive 5, and then set up another equation where 2x minus 3 is equal to negative 5. Now you're going to solve each one of these for x. Let's add 3 to both sides to get 2x equals 8, and divide both sides by 2 to get x equals 4. That's one of your solutions, and let's solve the 2x minus 3 equals negative 5 by adding 3 to both sides. And we get 2x equals negative 2. Dividing both sides by 2 will give us x equals negative 1. So our solutions are negative 1 and 4. You do need to check both of those in the original equation. Let's do our check step over here. When you check for x equals 4, plug that into the original equation. You get 2 times 4 minus 3, that quantity squared. Does that equal 25? Well, 2 times 4 is 8, and 8 minus 3 is 5, so 5 squared does equal 25. Let's go ahead and check x equals negative 1. That'll give us 2 times negative 1 minus 3. When we plug that back into the original equation, we want to check to make sure that is also equal to 25. And 2 times negative 1 is negative 2. Negative 2 minus 3 is your negative 5 squared, does also equal 25. So that's how we solve the quantity 2x minus 3 squared equals 25 using the square root property. In this example, we're solving the quadratic equation by using the method of completing the square. Beginning with our quadratic equation, x squared plus 6x minus 3 equal to 0. It's in standard form. Our goal in using the method of completing the square is to end up with a perfect square trinomial that can be factored. So our first step is to add 3 to both sides of this equation. When you add 3 to the left side, you want to add 3 to the right side of the equation. So we end up with x squared plus 6x, and notice the blank here. We're going to add something in that blank that makes this a perfect square trinomial. And on the right side, we have 3 plus another blank. And we have blanks on both sides because whatever we're adding to the left side, we're going to add the same thing to the right side, so that we're not changing the balance of this equation. Now, in order to make this x squared plus 6x a perfect square trinomial, we want to add something in that space that makes it a perfect square trinomial. And recall when we looked at perfect square trinomials such as x plus y quantity squared, when we expand it using the FLOW process and combining like terms, we would get something like this, x squared plus 2xy plus y squared. So what we're doing is looking for what number would make this a perfect square trinomial. And the trick here is to take half of that middle term and the coefficient of 6. Take half of 6 and square it. And since half of 6 is 3 and 3 squared is 9, we're adding a 9 in the space on the left side, and whatever you do to the left side, we're going to add the same thing on the right side. So what that does in this example is we end up with this trinomial, x squared plus 6x plus 9. This is considered to be a perfect square trinomial because the factors of 9 that add up to 6, those factors are 3 and 3. So we have two identical factors. So x plus 3 times x plus 3 are factors of that simple trinomial. And another way to write x plus 3 times x plus 3 is to write it as the quantity x plus 3 squared. Now that you have it in this case, you can use the square root property. Take the square root of both sides. And when you take the square root of both sides, you want to consider both the positive and the negative possibilities. Again, that's using the square root property. So now we have the square root of 12, which can then be further simplified, since 12 is the same thing as 4 times 3, and we're looking at the square root of 4 and the square root of 3, considering both the positive and negative values. We get x plus 3, since the square root and the squared power are inverses. Using the square root property will eliminate that squared power, so you end up with x plus 3 on the left side. And now you're going to solve these two equations, breaking it up, one with the positive and one with the negative. That should be a mistake there, sorry. This should be a negative 2 square root of 3 on the right. And then solving those equations, you get your two solutions. You can subtract 3 from both sides of the equation. So your x values are negative 3 plus or minus 2 square root of 3. So on the previous two slides, we did this method of completing the square. I'm going to recap the steps and go over a few more examples. To solve ax squared plus bx plus c equals 0 quadratic equations by completing the square, use these steps. Step number 1, be sure the squared term has a coefficient of 1. The squared term is your ax squared. You want to have that coefficient of 1, so you would divide out the a from all of the terms. Step number 2 is to write the equation in correct form so that terms with variables are on one side of the equal sign and the constant is on the other side. And then you have that blank, you want to make it a perfect square trinomial, and that's by squaring half of the coefficient of the first degree term. That's your b, your coefficient of the x. You're going to take half of it and square it. And that's what you add to both sides. That's step number 4. And step number 5, you factor the perfect square trinomial. One side should now be a perfect square trinomial. Factor it as a square of a binomial and simplify the other side. Step number 6 is to solve the equation by applying the square root property to complete the solution. Let's do the method of completing the square for x squared minus 7x equals 2, using the steps given. Be sure that the squared term has a coefficient of 1. That is the case already. So we can write this as x squared minus 7x, and I'm going to leave a blank here, and the 2 is on the right side. I'm going to leave a blank on the right side. So we're writing this equation in correct form so that the terms of the variables are on one side. Again, the variable's x. So all the terms with the variables are on the left side, and the constant term, 2, doesn't have a variable, so that's on the right side. Now we're going to square half the coefficient of the first degree term. Well, half the coefficient, the coefficient is negative 7. We're going to take half of negative 7 and square that result. So half of negative 7 is negative 7 over 2. When we square that result, we get negative 7 squared, which is 49, over 2 squared, which is 4. That's the number that we're going to place in the space on the left, as well as the space on the right. Now, on the left here, we have a perfect square trinomial. The factors of that last term that will add up to the middle term can be expressed as x minus 7 over 2, that quantity squared. Again, you can factor x squared minus 7x plus 49 over 4 by finding the factors of 49 over 4, which is negative 7 over 2, and another negative 7 over 2. And when you add those, you do get negative 7. And then on the right side, we have 2 plus 49 over 4. You can add those together, getting a common denominator, and write this as 57 over 4 on the right side. Now we can apply the square root property. Since we have isolated the squared quantity on the left side, we can take the square root of the left and the square root of the right, as long as we consider both the positive and the negative possibilities. And the square root and the squared power are inverses, so those will divide out, and we'll have x minus 7 over 2 on the left side, and plus or minus the square root of 47 over 4, which we can write as a square root of, 57 over the square root of 4, which is 2. Now we are very close to solving this equation for x. We can add 7 over 2 to both sides. Again, we're considering both the positive and the negative outcomes here when we use the square root property. Finally, we get x by itself equals this positive 7 over 2 plus or minus the square root of 57 over 2. These are our two possibilities, and you can check those in the original equation. All right, let's use example 8 and using the method of completing the square to solve this quadratic equation. Let's begin with the equation, writing it so that we have the x terms on one side of the equation and the constant term, that negative 7, we're going to write that on the other side of the equation. We can add 7 to both sides, and then we get 3x squared plus 6x on the left side and 7 on the right side. Now we do want to make sure that the squared term has a coefficient of 1. So we are going to divide by 3, as long as we're dividing everything by 3. And when we simplify, the 3x squared divided by 3, the 3's will divide out and we get x. The 6x divided by 3 is 2x. And then on the right side, we get 7 over 3. We'll leave that as a fraction. Now this is where I'm using the method of completing the square. I'm going to put a blank here and on the left side and a blank on the right side. We're going to add something to the left side so that this becomes a perfect square trinomial. And what we're looking for here in the method of completing the square is take half of the coefficient of the x term, which is 2, take half of 2 and square it. So half of 2 is 1, and 1 squared is 1. So that's what we're going to add in the space on the left. To keep this equation balanced, we're going to add 1 to the right side as well. Now we have this nice simple trinomial on the left side, and the factors of x squared plus 2x plus 1 are x plus 1 and x plus 1. That is always going to happen, that you're going to have a repeated factor. So this can be written as x plus 1, the entire quantity squared. And on the right side, 7 over 3 plus 1, we can write that as 10 over 3. Now we can apply the square root property to both sides. We could take the square root of the left side and the square root of the right side, but again, we need to consider both the positive and the negative outcomes. Okay, let's continue down the page here. When we simplify our next step, the square root and the squared power are inverses. So this is going to simplify to, simplify to x plus 1. And on the right side, it's plus or minus the square root of 10 over 3. Now we can write this as plus or minus the square root of 10 over the square root of 3. We can rationalize the denominator here by multiplying the numerator and the denominator by 3. Then our next step we can write as x plus 1 is equal to plus or minus the square root of 30 over the square root of 3 times the square root of 3, which is 3. We've rationalized the denominator. Now we want to subtract 1 from both sides so that we can get our answer as x equals this negative 1 plus or minus the square root of 30 over 3. So this gives us our two possible answers. As always, we want to check those in the original equation to see if they are correct. All right, let's look at quadratic equations with non-real complex solutions. In example number 1, we want to solve each equation. Part A is x squared equals negative 28. By applying the square root property, we can take the square root of the left side as long as we take the square root of the right side. And we do also need to consider both the positive and the negative possibilities when we are using the square root property. Now, the square root the square root and the power of 2 are inverses, so they're going to cancel out, and we get x on the left is equal to plus or minus the square root of negative 28. Now, negative 28 has it's square root of a negative, so as we looked at in the last section, that's an imaginary number. So we take out that imaginary part and write this as plus or minus I times the square root of 28. Now 28 under the radical can further be simplified because 28 is the same thing as 4 times 7. So we can write this as well as x equals plus or minus I times the square root of 4, which is 2, times the square root of 7. And then we can write our final answer as plus or minus 2i square root of 7. So one answer is x equals the positive 2i square root of 7, and the other is negative 2i square root of 7. Let's look at part B. We're going to apply the square root property by taking the square root of the left side. Since the squared quantity is already isolated, we can take the square root of the left side as long as we're taking the square root of the right side. Again, we're considering both the positive and the negative possibilities there. The square root and that power of 2 are inverses, so we can cancel those out to get m minus 2 equals plus or minus the square root of negative 25. Well, the square root of negative 25 is also an imaginary number. It's going to be plus or minus I times the square root of 5, or square root of 25, which is 5. So we can write that as plus or minus 5i. Now we can add 2 to both sides of this equation so that we get m is equal to that 2 plus or minus 5i. So one of those answers is m equals 2 plus 5i, and the other is m equals 2 minus 5i. And again, you do want to check those by putting those back into the original equation and checking your work. Let's solve this equation. We're going to use the method of the completing the square to solve this equation for x. Let's write the equation so that the x terms are on the left side of the equation. So we got x squared plus 4x. Then I'm going to leave a blank there, and that plus 11 I'm going to move to the other side, make it a minus 11, and leave a blank. Now that it's ready to use the method of completing the square, I want to take half of that linear coefficient, taking half of 4 and squaring it. I get half of 4, 1/2 of 4 is equal to 2, and then 2 squared is equal to 4. So 4 is what I'm going to add in the space on the left, and whatever I add to the left side of the equation, I'm going to add to the right side of the equation. This now becomes x squared plus 4x plus 2. This is now a perfect square trinomial. We can factor that, and the factors are x plus 2 times x plus 2. And on the right side, negative 11 plus 4 is negative 7. We can write the left side as x plus 2 quantity squared. Because that is a perfect square trinomial, using the method of completing the square will always result in a perfect square trinomial. So we get the whole quantity x plus 2 squared equals negative 7. Since the squared quantity is isolated on the left, we can then apply the square root property. We can take the square root of both sides, again, as long as we consider both the positive and the negative outcomes. Then the square root with that power of 2 are inverses, so our equation becomes x plus 2 on the left side equals plus or minus the square root of negative 7, but that square root of a negative is imaginary, so we can bring that imaginary unit out in front and write this as plus or minus I square root of 7. Now we can subtract 2 from both sides to get x by itself, and we get x equals negative 2 plus or minus I square root of 7. So x equals negative 2 plus I square root of 7 is one answer, and x equals negative 2 minus I square root of 7 is another answer.